everyone, welcome to my channel. In today's video we will discuss first law of thermodynamics. Let's begin with the statements. Energy can neither be created nor be destroyed. This means during a reaction we will not create the energy, or the energy already present that will not be destroyed, but it may convert it from one form to another. Means during any reaction we will not create a new energy, or we will not destroy the energy already present. So that energy already present will get converted into another form of energy. For example, to switch on the fan we need electricity. Electric energy is required. When the fan is on, fan uses electric energy and the blades were moving. That electric energy gets converted into mechanical energy. No new energy will be created, and the energy already present, that is electric energy, that will be converted into mechanical energy. So this is the meaning of first definition of first law of thermodynamics. Now, second definition, total energy of the universe remains constant. Now what is universe? Universe we have already studied. Universe is system plus surrounding. System is anything which is under the consideration or under observation, that is system. Rest all things around that, that is surrounding. Together these both terms will make the universe. So total energy of the universe remains constant. Total energy remains constant, although it may undergo transformation from one form to another. The meaning of this definition is also same. Means the total universe ਦੀ ਜਿਹੜੀ total energy ਹੁੰਦੀ ਹੈ ਉਹ constant ਹੁੰਦੀ ਹੈ, but ਜਿਹੜੀ ਉਹ energy ਹੁੰਦੀ ਹੈ ਉਹ ਇੱਕ form ਤੋਂ ਦੂਜੀ form ਦੇ ਵਿੱਚ change ਹੋ ਜਾਂਦੀ ਹੈ. It may transfer from one form to another. Similarly, as we said in earlier definition, it may convert it from one form to another. Energy of an isolated system is constant. Now what is isolated system? We have studied three types of system: open, closed and isolated. Isolated system is in which no energy or no matter, no energy, no matter get exchanged. Means neither energy nor matter. Means the substance will not pass from that system to another, as well as the energy will also not transfer from that vessel to another. So that system is isolated system. So energy of such system is also constant. These are the three definitions of first law of thermodynamics. Now let's continue with the observations of first law of thermodynamics. In observations, first is whenever a certain quantity of some form of energy disappears, means whenever some form of energy disappears, an equivalent amount of some other form of energy is produced. What does it mean? This means when one form of energy disappears, then another form of energy gets produced. Let's understand with example. Suppose we supply electricity to the electric heater. From electricity, the electric heater uses the electric energy. Certain quantity of some form of energy disappear. That electric energy disappears because it is used by the electric heater. An equivalent amount of some other form of energy is produced, and that electric heater uses the electric energy and it will gives us heat in the form of heat energy. So some other form of energy is produced, that is heat energy. Now second point, it is impossible to construct a perpetual motion machine. Now what is this perpetual motion machine? Perpetual motion machine means it is that type of machine which will not consume any type of energy, but it continuously works. Think yourself, is this type of machine will be possible that will not consume any type of energy but it works continuously? Practically it will not be possible. So it is impossible to construct a perpetual motion machine. Third point, there is an exact equivalence between the heat and work. There is the exact equivalence, means if we did work 4.184 joule, then 1 calorie heat is produced. Means there is exact equivalent value, means for this amount of work done, this amount of heat is produced. So this is 1 calorie heat is produced if 4.184 joule work is done. These are certain observations to explain first law of thermodynamics. Now we will discuss mathematical expression. In mathematical expression, we will discuss another form of energy, that is internal energy. What is internal energy? Basically, internal energy is the sum of all the energies present in the system. All the energies means kinetic energy plus potential energy plus translational energy plus rotational energy plus vibrational energy and so on. These all kinds of energies, their additive sum will gives you internal energy. Now we have already studied that internal energy is a state function. Now why it is state function? Because internal energy is a state function because it's very difficult to calculate all the energies and the sum. Their sum will give you internal energy. It's very difficult to calculate rotational energy, vibrational energy. So due to that reason, internal energy is a state function which depends only on initial and final states. Internal energy is represented by U. Now we will derive an expression. Suppose initial internal energy is equals to U1 if it absorbs Q amount of heat. Now you tell me, this Q will be positive or negative? If it absorbs means system nu heat ditti ja rahi hai. When the heat is given to the system, then it is always positive. So it is plus Q. And then internal energy will become internal energy U1 plus Q. Then new internal energy will become this. Now if W is the amount of work done on the system, if W is the work done on the system, then it should be positive or negative? It will be positive, plus W. Now then internal energy will become, then it will become equals to W1 plus Q plus W. Now we have to find final internal energy. Final internal energy we can represent it with U2, and then it will become U1 plus Q plus W. We can also write it as U2, U1 will bring here, minus U1 Q plus W. We can write it as delta U because it is a change. So delta U is equals to Q plus W. This is the expression for first law of thermodynamics. In this, delta U is change in internal energy Q is heat and W is work done. That's all. You have already seen this expression when I explain you the sign conventions. Basically, this is the expression for first law of thermodynamics. Now, if we consider further, mark this as equation 1. Now, if W is equals to minus P delta V, then using second in first. Instead of W, you can put this value. So, delta U is equals to Q plus minus P delta V. Then it will become Q minus P delta V. Or you can also write it as Q is equals to, Q will remain this side, delta U plus P delta V. This is the another expression. After this, we will get some conclusions from these expressions. Now, these are some conclusions which were derived from the first law of thermodynamics. What is the expression of first law of thermodynamics? That is, delta U is equals to Q plus W. Now, we will discuss each conclusion. First is U is the function of temperature. If U is the function of temperature, then we can write for isothermal. If the condition is isothermal, then delta T means temperature changes what? 0. Then if temperature changes 0 and we are saying that U internal energy is the function of temperature, then internal energy will also be equal to 0. Got it? For isothermal irreversible expansion, this is the expression for irreversible expansion work done. In isothermal condition, what will happen? In isothermal condition, temperature will be constant. According to this expression, in isothermal condition, what will happen? This will become 0 and this Q will become here, will be here, and W will move here. Then it will become minus. So we will get Q is equals to minus W. For irreversible expansion, we have the expression minus P delta V. When we put minus P delta V instead of this W, negative negative cancel and you will get this expression as your answer. Next, for isothermal reversible compression or expansion, you have this expression. Similarly, if the condition is isothermal, then delta U is equals to 0. If delta U is equals to 0, then Q will become equals to minus W. So, minus W, this expression is basically in positive form, but here is negative, so negative sign. You will get the expression with a negative sign. Next, isothermal expansion of ideal gas against vacuum. Vacuum means when there is a free expansion. In case of free expansion, work done and heat will be 0. If work done and heat both are 0, then internal energy will be equal to 0. Next one is adiabatic process. Adiabatic process, we already know there is no heat change. Means no heat enters the system and no heat leaves the system. So in case of adiabatic process, Q will be equal to 0. If Q will be 0, then delta U is equals to W. Last, cyclic process. In case of cyclic process, we have already studied that work done will be 0. Suppose a person starts moving from here and after moving the whole path reach the same way. We are saying that he will not did any work. For cyclic process, work and heat is 0. So for cyclic process, internal energy will also be 0. This is all about first law of thermodynamics. Keep watching for more such videos of thermodynamics series. Thank you and have a nice day.